All right, you guys, we're going to go ahead and take some peeks at topographic maps. And I'm sure for those of you guys who are my hunters, hikers, fishermen, you guys have seen maps like this that resemble this at some point in time. I made sure in the packet that I have for you guys, I do include areas. If you're from around here, you kind of understand some of these features. This one here has Fredonia Pass. This is considered Moonlight Peak. As we move through the pack, there's Lake Almanor, there's areas by Old Station, Greenville, all kinds of stuff. So I want to start by making sure you guys understand this legend. You're going to need to use this when you go to do the assignment today. And if for some reason you're not able to print this out, it's not a big deal. You can go ahead and just write all the responses or answers on a separate sheet of paper. So you can see here boundaries that resemble that of a national forest versus a wilderness area versus a ranger district. Other things that you're really going to need to know for the sake of this map are the different types of roads. I want you to know what a dirt road versus unimproved road versus a closed road looks like, because some of these roads, like the forest unimproved road on the bottom, you're going to see a lot of those that have the N, 32N46. If you've ever driven around any of these roads back in the country back here, you've seen numbers and letters that resemble that with that N in it all around this area. When you see areas like this that have these numbers, a lot of people are going to think this is elevation. It's not. Those are trails and the trail number. You have different types of areas that show Savile Grand lava, whether there's different types of water features that are present. Basic topographic features, we're going to go over contour, index and interval, and spot elevation. These are the most important ones for you guys to understand for today. Now, take in mind, if I was to have you make a true legitimate soil map, we would also have to take into effect elevation and changes in elevation, but it's kind of hard to bring a bunch of survey equipment and teach you guys how to survey and do topographic maps and soil testing and to turn it into an appropriate soil map. So ours is definitely going to be like an easier version of it. So if we go ahead and we take a look at this first example here, there's a lot of little lines on there. You guys can see major roads running through, definitely where it comes to some areas where you have steepness and mountain peaks, probably have some form of water systems or steep cliffs, areas that have been designated as national forest versus areas of just plain wilderness. There's definitely a lot of large features over here. You can see this is Bald Mountain for those of you guys who are familiar with this area. So in order to teach you guys how to read that correct, I have to teach you guys what a contour interval and a contour line is. So for those of you guys who don't know, I'm here in my classroom at the high school. So for those of you guys who know where this is, that's why I'm on this type of a, I can't even think of words today, whiteboard for you guys. So every single line on here is a contour line, and it's important that you guys know that. And it shows areas of equal elevation. So if you follow this line and it shows 700 here, you know that this line is 700 feet in elevation all the way around. It never changes. It's always going to stay 700 feet. And that's what contour lines do, is they connect points of equal elevation. You're going to have to be able to find contour interval on here. And contour interval is a little tougher. So contour interval is the distance between two contour lines. And once you guys know what that contour interval is, and you guys are looking at maps like these, you can figure out that distance. And when you get places like this, you can go, oh my gosh, that is super, super steep. Definitely not a mode of place I want to travel. If I'm going to cross from here to here, I'm not going to go this way. I'm going to loop around this way because it's definitely way less in elevation change. So to figure out that interval, we know this is 700 feet. We know this is 900 feet. This is a spot elevation. It gives you the exact elevation of 972 feet at the top of that peak. But to figure out that interval itself, this is how you do it. You take your two known elevations. I know this is 900 feet. I know this is 700 feet. You take your 900 minus 700, and you get 200. So you know from here to here, it's 200 feet. Then you have to count how many intervals. Well, this was my first line, right, that has 700 feet. So from here to here, that is one interval, the distance between two contour lines. Then from here to here is my second interval. From here to here is my third interval. And from here to here is my 4th interval. You're not counting lines, because if you count lines, you're going to go 1, 2, 3, 4, 5, and you're going to get the wrong number. You're counting distance. So I always start on my first line and go 1, 2, 3, 4. So we're at 4 intervals. So 200 divided by 4 is 50 feet. So that is my contour interval on this map. And to make sure that that's correct, this is the easiest way to go. So this is 700 feet. So this would be 750. This would be 800. This would be 850. That would be 900. This would be 950. And we know that that can't be 1,000 because it doesn't go up to another line, so it gives it its spot elevation. And that makes sense. You guys are going to have to be able to read these intervals for the assignment. A lot of times when you have your known elevations too, the other thing they do is they really darken these lines for you guys. So these lines pop out at you. So when you guys are looking at those soil maps, you're going to look for those dark lines, follow them down to where you get the known elevation. Now, let's say that we were going downhill, and this happens in some of your guys' maps, okay? Over here, it doesn't show that it's going downhill. It doesn't show any numbers. Hypothetically, if our interval is 50, and you know this is 700, you could say 7, 750, 8, 850. This is between 850 and 900. And I don't have any lines on here. But what would happen is if this was going downhill into like a depression, at the very end, they're going to have these little lines that show this. And this is showing that it's moving down. Okay, so we know that it's moving downhill, and we know that this is 700. How do we know it's 700? Because we follow this line over here. That is 700. So instead of adding 50 every single time, we're going to subtract 50. So now we know this is 650. This is 600, and this is 550. But the key is, and this is going to be a tricky one, what is the exact elevation? Right here in the middle. This one, this spot elevation, tells you the exact number. But on this side, it doesn't. It leaves it open. So if I was to ask you, what is the elevation of point A? Okay, we know it's greater than 550. But we know it's not 500, because if it was 500, there would be another line, right? So we know it can't be 500. So technically, it's 550 feet because it can't be 500, so it could be 501 feet. So it's somewhere between that. So if that's the case, and I asked you what the point of elevation A is, that's what you would put. So what you guys are going to do today, as the first part of this assignment, is I have this map that has a whole bunch of numbers written on here for you guys to try to figure out different types of elevation. So you are going to start at point A, and you're going to try to figure out that exact elevation of point A. Remember, if this line right here is super, super dark, and it connects here, that shows you that's 6,000 feet, and you see that it goes to 640 feet, maybe you know if that elevation is increasing or decreasing. So you're going to find that line right there, and on a separate sheet of paper, you're going to write point A, and you're going to tell me everything you know about point A. It's definitely more in an open area that's not close to a hillside, because you have a lot more gaps between areas here. It's close to this road, 29N46, so you could identify that it's close to that road. You could identify that if it's increasing or decreasing over here in elevation. So you're going to put point A, you're going to tell me the exact elevation of point A. You have to do the math, showing how I just showed you how to do it. And then you're going to tell me about the features. Is it close to water? Is it close to a draw? You know, draws are areas a lot of times where like livestock, game, all those will travel down. So if you look at this area right here on the map, and you can see how these lines kind of connect and fold into V's on their way down, that's where animals are going to travel. They're going to walk through that draw, that area that probably has some freshwater resources as well. And that's where they're going to travel and go into. So you can use that to your advantage. So you have letter A, letter B is easy on a line. Letter C takes multiple lines. So you can pick any of those lines to identify, or everything in between. It's completely up to you. Sorry, I'm sniffling in the background. I'm a little sick myself. And then you have D. I want to know what the elevation is on the inside of that little circle. And so that one's a little bit harder to figure out. E go ahead and point to this line that's right here. I want you to figure out what that is. F, we're on this very specific line over here by the lava tubes, if you guys have ever been over there. G, now there's a ton of lines. We're leading up to a top of a really big Sugarloaf Peak over here, for those of you guys who've ever been over to Sugarloaf. And so you can see that there's this dark line right there, kind of on the edge of the G, if you can measure that elevation. H would be the top of this mountain right here. I, as I want to know what's on this line that crosses over here and also identify that road for me. And J, what is the elevation here in this valley area? And then I want you to go ahead and put marks of your own, just like this, in 3 other spots on any of the other open pages and identify those features as well. So this should take you at least a solid half hour, 45 minutes for you to go ahead and to properly identify those. And this might be a little difficult for some of you guys. You may have to watch this video a couple of times. You may need to rewatch how you figure out that contour interval and spacing to get that lined out. But I know that you guys can do that. So you're going to use this along with the next video that has to do with my pacing to figure out how to draw a soil classification map.